So finding a line based on data is our continued objective here. So there's a video, feel free to check this out on your own. I have another one in the playlist of me doing a similar experiment where I have a spring and I'm putting weight on the spring and I'm watching how much the spring stretches. And I'm recording the spring stretching compared to the weight I'm putting on it. This is a friend of mine, David, who's doing a similar experiment where he's putting weight on a spring and seeing how far it stretches. And so what we're going to do is we're going to not worry about the video for the moment. We're going to take his data and see what it looks like graphically. And this is, it's not too hard to do this one by hand. It is doable. It's nice to have a grid already laid out for you with numbers on it. Right, so our first goal is to try and plot those points here, but I want to show you how a spreadsheet does this also. Now, when I write down my data, I like it to be vertical, not horizontal. Like I like a column for my X values and a column for my Y values. And so that's what I'm going to go for in just a sec on my spreadsheet, and then we'll try it here. So I have the mass in grams. So we're putting mass on the scale, and we're watching the spring, and we're watching that spring stretch. And this is kind of how real scales work. There's some kind of spring. Sometimes we watch the spring compress with the weight, like think about springs in a car between the suspension in the car between the tires and the rest of the car. Those springs are compressed based on weight. Here we have a string that's stretching based on weight. So the mass here would be my input, my independent variable, and then the output, the dependent variable, is the height. So I'm going to go over to my spreadsheet and get this started. And so sometimes I call these my X values and my Y values. Here I'm calling the mass and height. And my masses were pretty nice numbers. They were 50, 100, 150. So 50, 100, 150. And again, I just like them vertical, X's in one column, Y's in the other. And then my heights were 25.8. 21 and 16.2. And we can get the spreadsheet to graph these for us, which is kind of neat. So I've shared some spreadsheets before that had graphs I pre-made. So I'm going to show you how we could do that on our own. So once we have this into the spreadsheet, and really all I want is a title and the data for one, and a title and a data for the other. And what I want to do is I don't want the X and the Y up there. I just want the mass, height, and their numbers. So I highlight my data with their individual titles. I happen to have extra titles. We're going to ignore those. And then a couple ways to do it here in Google Sheets. I could go to Insert and say, can I have a chart, please? Similarly, in the toolbar, there's a chart over here. Now, it depends on the size of your screen. If your screen was a little smaller, then you got to go hit the More button and then find the chart. So I'm going to use the Chart button, insert a chart. And the computer's going to guess. And sometimes it guesses right. I wanted to plot points, and on a computer, that's called a scatter plot. So I just had the computer make a scatter plot for me. And notice it chose to go 50, 75, 100, 125, 150. Notice it's choosing these nice evenly spaced numbers for me. And it made a guess at that looking at my data. And even though the heights weren't like nice numbers, like 21's nice, 20's nicer when I say nice with numbers, but they're all right. And it just said, okay, we have to spread this range. Let's try going 0, 10, 20, 30. And if I point and click on one of these, sometimes you can get it to tell you what it is. Okay, it just wants to edit it there. I don't want to edit it. All right, so that's it, plotting the points. Boom, I got them there. I want to try and do a similar thing on that other homework assignment. We'll come back to this in a minute with a line. So then, to the best of your ability with your mouse, plot the points. So let's see, read the instructions carefully. Use the dot tool to plot all 3 points from the video, which are summarized in the table here. then switch to the line tool and draw a line that passes through the points. Okay, mass is horizontal, and that's my x values, my mass, and height is vertical, those are my y values. So I need to plot 50, 25.8. So here's 50, and then I gotta find 25.8 is a little under 26. So it goes 24, 26, 25 would be in the middle. That's pretty close to 26, maybe there-ish. And if you don't think you put it in quite the right spot, you can always tweak it, try to move it a little bit. All right, next, 21, 100, sorry, 121. 100. 21's easier to grab. It's right in between 20 and 22. Ooh, a little off. Again, we can move them till we get it right. Oh, that looks nice. And then 150, 16.2. So just a hair above 16, maybe there. Looks a little too high. And we got a little wiggle room for error. Okay, there's my points. 150, 16.2, and I'm taking a piece of paper and I'm holding it up to my screen to see if I got 16 on the right line. I don't know about you, but sometimes it's hard to look all the way across the screen and see if you're at the right level. My eye tends to jump lines accidentally. 121, looks a little high, but not bad. Yeah, so my middle point's a touch high, but I think I'm gonna go for it. And then I wanna try and draw a line through them. So I'm gonna kind of do what I did before, maybe start at the first one, go to the last one. Hey, those three line up pretty nice. Wow, that's awesome. Cool, I'm going for that right there. That looks like my line. All right, so do your best with yours. Try and plot those, submit it, hope you get it right. And again, if you think you're close enough on this, but the computer didn't like it, feel free to message me and say, yo, Parker, I think mine was close enough. Can you check it out for me? I'll be glad to go look, give you a yay or a nay on that with my reason. All right, write an equation. We can do this. Write an equation. So I'm going to take my vertical version of that list right there and just write it down on my paper. Okay, so this is the spring scale problem. Lesson 3.6. And I have a graph or a table. Let's start with the table. And I have my X's and my Y's. And the X's were my masses and the Y's were the heights. And the heights were measured in centimeters, my recollection, and the mass was measured in grams. Let's double check, make sure I'm making that shit up. Yeah, grams and centimeters, good. Okay, and we had nice masses. Ooh, that's not a nice 5. What happened there, Gary? 50, that's better. 100, 150. And then 25.8. 21, 16.2. And I want an equation, the kind of standard one we go for, y equals mx plus b. And I may need to rename y and x, and I have to calculate m and b. So the starting value, that's always the point 0b. I don't have 0 on my table here, unfortunately. So I'm going to have to try and figure that out. And they don't give me m. So let's look back at our graph. Well, since I picked the first and last point for my line, I guess I'm going to use those two to come up with the slope, because that line right there seems to go through the middle. And then looking at the picture, I have an estimate of the y-intercept. Mine looks to be around 31-ish. We'll calculate that to confirm. Because again, I could have made a mistake plotting here. So we'll calculate to confirm our picture. Okay, so I'm going to pick, again, the first and last point. So this point here, and this point here to get my slope. And then we'll backfill maybe with this one right here to find the y-intercept. And then we'll fix our variables. So my m, that's always the change in the y values divided by the change in the x values. So that's going to be a 16.2 minus 25.8 over, and we got to get the order right, 16.2 has to go with 150 and minus 50. And I'm just going to whip out a calculator to do this. And reminder, a spreadsheet is a calculator. And I've already got these numbers in my spreadsheet. All right, so if you already started this spreadsheet, you got this much right here. If you didn't start it, I'm going to share this with you right now, and you can just grab mine and play along. So let's see. Anyone on the internet with this link can view it. That's what I want. I'm going to give it to you. If you're watching this on YouTube later, look in the description under the video. You should see this link. All right, it's copied. So I'm going to put this in the chat to you all if you want to check it out. And then if you open up your Zoom chat, click that link, it should pop it into your browser. And if you're a Google user and you're already logged in, then you should have the ability to copy it. So for example, if I go to, let's say one of my other Google accounts here, let's pick Coach. Where'd you go, Coach? There you are. And I enter that link in there. I'm logged into my Coach Google account. And at the moment it says view only, but if I want to play with it, right, it needs to be edit. So then what I want to do is make a copy for myself. So if you want to take off where I left off with this and do stuff like me, then make yourself a copy. And copy of always annoys me. So I'm going to call this Gary's lesson 36. And so now I have a version I can edit. If you're not a Google user and you opened this up, right, like you're not logged into Google, let's go to an incognito window and drop this in, then it would look like this, a little bit different, but similar. You could sign in if you have a Google account, but if you just don't, say, I don't want a Google account, then what you would have to do here is you have to download this and open it up and say Microsoft Excel if you happen to have Excel on your computer, or maybe you're a Mac user and you're going to use Apple's numbers, which I find annoying, but pretty. Okay, so there's a whole bunch of us logged into this here. Okay, and here's my personal version for my other person. And once I've made a copy, it's different than the one I'm working on. So like if Coach goes in here and types stuff, Coach can't spell. When I go back to my original one, like there's no stuff there. All right, so I'm going to do a couple of things here. I'm going to use the first and last point to calculate the slope, just like I did in my notes. So in my notes, oops, wrong button. Notes, there you are. Nope, there you are. There we go. I need to tell the computer how to do that right there. So when you tell a spreadsheet to do something like this, it's not like Desmos where it makes a stacked fraction for you. We would have to put parentheses around the numerator and the denominator when we enter this in. The other thing is I don't need to write 16.2 because it's already on my spreadsheet. So here's how we make that happen. So I've already typed the numbers. Let's see, come on, where'd you go? There, in here. So let's say underneath here, I'm going to make a place called slope. And then next to slope, I'm going to type my calculation. So to do a calculation on a spreadsheet, you type equals. From my notes, I reminded myself I need a parentheses. And then I want to take the second y value, just click on it, the hyphen or dash for subtract, and then click on the first y value. So that's my numerator. Then I got to close the parentheses saying, okay, done with the numerator. And then the division is the slash on the keyboard near your shift or your enter or return key underneath. So it's the slash going to the upper right, not the other one. That means divide, denominator parentheses, and then click on your denominator numbers minus the other. Close parentheses, hit enter, and we got ourselves a slope. So I'm getting a slope of negative 0.096. sometimes when I'm working on a spreadsheet and I'm doing a calculation I'm not familiar with, I usually back it up with another calculator. So I'm going to go to another calculator and just make sure that that matches, that I didn't screw up my parentheses there. Doesn't hurt to double check. Desmos is a cute one to use because it does that stacking fraction. I don't have to worry about parentheses. So my numerator was 16.2 minus 25.8. And then arrow down to the denominator or click there. And that one was 150 minus 50. And I'm getting the same number. Okay, so I did it right in the spreadsheet. If in your spreadsheet you didn't get the same number as me, I'll just repeat what I did there. To do a calculation, you have to do equals. Since this calculation is complicated, right, it's got a whole bunch of stuff in the numerator has to have parentheses. So I go parentheses, and then I just don't retype the numbers. They're already on the screen. Just click on them. Click, minus, click. Just make sure you click in the right spot. Divide, parentheses again. Click on the X, minus the other X. Make sure you get the order correct. And I get the same number. Cool. So there's my slope. For the y-intercept, I got to write some stuff down on paper. So I have a slope of negative 0.096. Let's make a note of that on our paper. And let's also make a note of the correct variables. What did they ask us to use? I think it was like a W and an H and a D maybe, or no, it's a different problem. Let's see, you're over here. Down here, okay, H is height, W is the weight, okay, H and W. Okay, H is height, so instead of a Y, I'm gonna have an H and a W instead of an X. So instead of Y equals, I want H equals, I know M is negative 0.096. Instead of an X, they want a W, and I still don't know B. But I can plug in a point, and then I will know B. So I'm just going to enter 50 for the W here. That has to be multiplied by negative 0.096. And then I'm going to enter the 25.8 for the height. Make sure you put those in the right spot. Now I filled in everything but B so I can find B. So I need to take 50 times that and then bring it to the other side. So let's double check that on our calculator. I'll go back to Desmos here. So what is that slope times 50? I get negative 4.8. And for new calculations to me, I'm in the habit of calculating and writing it on paper. So negative 4.8 there plus B is 25.8. And then I need, since that's adding a negative, I need to add that as a positive to the other side. And 8 and 8 is 16, carry the 1, 5, 6, 10, carry the 1. It looks like 30.6. Double check on the calculator. So then I have my 25.8 plus my 4.8, and there's my 30.6. And I could have done all those calculations here too. So I could do them in one shot here. I could say my y-intercept B, and then I got to start off with equals. And if thinking about that equation, I had to modify that 25.8. So I think I'll start with the 25.8. And then I am going to, let's see, signs are getting tricky here. I guess I'm going to just do plus my 4.8 that I calculated. And there's my 30.6. I guess that's the easy way to get that done there, given what I wrote on my paper. Where's my paper? There it is. All right, so I think I have an equation, but we really should double check. So I think that I have H equals negative 0.096 W plus 30.6. And how could I check this, right? So I could just plug it in and submit and see if I'm right or wrong, but then I run the risk of getting it wrong. I want to know before. So the way to check it is to plug in like this number and see that you get back that number. So if I were to take negative 0.096 times 150 and then add the 30.6, I'm really hoping I get 16.2 back. Let's check it. So I'm going to come down here and do a little check on my spreadsheet. You could do it in Desmos too. And for my check, I think it should be equal to my slope times the 150 here plus my y-intercept. So I could click on the numbers because they're there. I could have retyped them, but that seemed like a waste. Enter, 16.2. It does check. Okay, so I'm now confident I have the right equation because I was able to reproduce a y value based on an x value with it. So we have an equation too. All right. So we got that part. What does the equation tell us? Okay, if no weight is on the hanger. I think I made a note about that earlier. Let's go back to the notes. Yeah, so when I was thinking about what the y-intercept meant, let's get a highlighter up there. This y-intercept B is really the point 0B, and 0 is no weight. Okay, so the y-intercept tells us if there's no weight, the bottom of that thing should be at 30.6 centimeters. So that's what the y-intercept tells us. I can note that on my paper. All right, so that's what the y-intercept tells us. So we have to, when we interpret a y-intercept, we want to both interpret what 0 means, that's supposed to be a check there, and what that number means. So I have both of those in there. No weight is my 0, and then there's my 30.6 centimeters. Now, how about the slope? Let's think about that for a second. Slope. Slope is rise over run. In this case, the rise, that was the change in the height. And what I'm writing down here, I recommend anytime you're asked to interpret slope, write this down first. And then the run, that was the horizontal, that was the change in weight. And we calculated that to be negative 0.096. Now that's not a fraction. So if your slope isn't a fraction, the last way you wrote it, just divide by 1 and make it a fraction. Okay, so this tells me that the numerator is a height. Height are measured in centimeters. Right, height, and the weight we were measuring in grams. So this tells me the negative means I'm going to lose 0.096 centimeters for every gram I add on. So we expect the spring to drop or decrease, I'm going to use drop, by 0.096 centimeters for every additional gram, or for an increase in 1 gram. I think I'll go for an increase in 1 gram. Let's back up here. For an increase, because I'm viewing the top as negative and the bottom as positive, of 1 gram of mass. So I want to write a sentence that describes what we see in that table and what the slope we calculated is. All right, so you want to fill in the pieces on that problem to get a sentence similar to that one right there. So I'll give you a moment to do that. Then we'll try to figure out the mystery block. And I'll show you a cute spreadsheet trick. Okay, so a mystery block of wood pulled down the hanger to 24.5 centimeters. We want to use our linear model to estimate the mass of the block. Okay, so let's see. They're telling us the new height is 24.5. We want to know what the mass is. So let's look at our equation. We've got H equals, let's switch colors there, negative 0.096 times the mass, what were we using for that? And W for the weight. Okay, W plus 30.6. And they're saying that we have a new height of 24.5. So here is my 24.5. I got to figure out how to solve for that W. Okay, well, our usual procedure is we go for the thing that's added or subtracted. So let's get rid of that with a little minus. Maybe whip out a calculator to help with that. And then we can divide. I'll switch over to Desmos again. So let's see, we had 24.5 minus our 30.6, and so that gives me negative 6.1. So this is gone, so negative 0.096 W. So that's a multiplication. To get rid of the multiplication, we divide. So a number divided by itself is 1. 1 times W is W. So over here, we also have to multiply by that same value to keep things equal, balanced. Negative divided by negative is a positive. It's good to know. So I'm going to take 6.1, divide by 0.096, and I get, I typed those right, 63.5-ish, 63.5 what? Grams? Oops. Right, because it's a weight, a mass, and this is approximate. I had to round to get that. How could I check? Well, I could plug that 63.5 back in, see if it produces the right height. Oops, wrong button. Want this here. So I'm just going to double check that. If I were to take my original equation, negative 0.096, multiply in a 63.5-ish, and then add on the 30.6, I should get about 24.5, which I am. This is checking out good. And round to 1 decimal place. Perfect. I just happened to do that. Good thing I read the directions. And for the cute spreadsheet trick with a warning about it. All right, so hopefully those questions went well for you. Back to my spreadsheet for a moment here. It turns out you can ask the spreadsheet to try and make a line through these points. Now, when I made this line, I only used the first and the last point, and I had to do the calculations here. Oops, wrong button. When the spreadsheet does this, it's going to try and use all 3 points at the same time. It's a little more complicated procedure than I did right here. And we're not going to go over how the computer does that. We're just going to let it do it and see what happens. And later I'll talk about how that's different than the way I do it. But bottom line is when I make a line, I pick 2 points, like I picked this point here, and I picked this point here. And I only considered those 2 points for the line. When the spreadsheet does it, it's going to think about all 3 points. And based on all 3, it's going to come up with what it thinks the best slope and y-intercept is, which will be slightly different than mine. So here's how I do it in Google Sheets. I click back on my chart. And then I say, I want to edit my chart. And I'm going to customize it. And we are going to customize the series. And the series are my points here. And then there's this option down here under series called Trendline. So it's going to look to see, is there a trend to these points? Let's say there is, and it's going to say, this is what I think the best equation for that is. So I click Trendline, and it draws a line, looks a lot like the line I drew. And then to get it to show me its equation down here, I ask it to label the equation. And it says, oh my God, it's the same line. Whoa, wow. Okay, doesn't always work out that nice. Sometimes it's gonna be a little bit different. Okay, so these points, 3 points line up enough that I get the same line. Won't always work that way, because where we only pick 2 points, the computer looks at all of the points to come up with that. So we got lucky. All right, and I will show that again in the future, I promise. Next, moving on.